Good day, class. In this lesson, we will learn to solve quadratic equations using the quadratic formula. Remember that solving quadratic equations in general offers us several different options for our approach. Remember that we can use the factoring method, the square root property method, the completing the square method, the quadratic formula method, or a graphing method. Today we'll look carefully at the quadratic formula method. In order to use the quadratic formula method, you must know or have access to the quadratic formula. Remember, there are many snazzy songs that are available to you, probably right there in your classroom, that offer you a peek inside of some of the creative things that many people have done with the quadratic formula in terms of memorizing it. But I guarantee you, after using it on enough practice problems, you will have this formula memorized. Notice how I have x equals on the left. I have that there because I want to remind you that using this formula yields the values of x whenever we're using x as our variable in the quadratic formula. But remember, the variable can be many different letters that we use for variables. So just keep in mind, solutions for your equations are found by using the quadratic formula. Note, I read the quadratic. Now, you'll be given a quadratic equation. For example, the equation that you see here, x raised to the second power plus 6x plus 5 is equal to 0, or x squared plus 6x plus 5 is equal to 0, and you may use the quadratic formula to solve for the value of x in this case. Keep in mind that using the quadratic formula can potentially yield two solutions because we are dealing with the quadratic equation. So look forward to two solutions. Sometimes you'll get two solutions, sometimes you'll get one solution. But the quadratic formula always solves an equation that has a solution. The quadratic formula will always work. Let's take a look at an example. We're going to use the quadratic formula to solve this quadratic equation. We've been given x squared plus 6x plus 5, and we're told that that is all equal to 0. Now, sometimes it may not all be equal to 0. So remember, make sure your quadratic equation is in this format where everything is all together on one side of the equal sign and you have 0 remaining on the left or on the right. That is required in order to successfully use the quadratic formula because you'll have to be able to identify the value of A, the value of B, and the value of C. Remember, these are our representations that we're going to use. I pointed out by the coefficients of each of your terms. Your x squared term coefficient is our A. Your x to the first coefficient is our B, and your x to the 0 or your constant is our C. Therefore, as you can see in this equation, the coefficient of x squared is 1, therefore A is 1. The coefficient of x is 6, therefore B is equal to 6, and the coefficient of the constant, I could say the coefficient of the x to the 0 variable is 5, but the constant here is 5. Either way you want to look at that. And so now we have the values of A, B, and C that we can substitute into the quadratic formula. We want to use the opposite of B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. And so I'll substitute those values. Remember, when you have a formula, all you do is substitute. So we're going to take those values, substitute them in very carefully into our formula, and we'll simplify. And that's really all that you have to do when you're dealing with the quadratic formula. At this point, we're just going to follow the order of operations and make sure that we carefully simplify. Notice some of the things that always happen when we're dealing with the quadratic formula. Take a look underneath that radical sign. I have simplified that power, that 6 has been squared. And so we become very familiar with squared values of many of these numbers that we work with quite often. And notice how that 4 times 1 times 5 has simplified. Notice how on the outside at the very beginning of our formula, we have that -6. That negative kind of just distributed in there, so I dropped those parentheses. And then in the denominator, all that we had was 2 times 1, so it just became 2. And so I'll continue to simplify what happened under that radical. I love to see when this happens, I have a perfect square underneath that radical sign. I have the square root of 16. I like that because that simplifies quite easily. So we continue to look for what can simplify here. And so now notice how I went ahead and broke out my two potential solutions. On the left, I have -6 plus 4, because that square root of 16 became 4, all divided by 2. And on the right, I have -6 minus 4, all divided by 2. These are my two possibilities. And so I simplify these even further, and that -6 plus 4, all divided by 2, simplifies to -1. And on the right, the -6 minus 4, all divided by 2, simplifies to -5. Therefore, the solutions to this equation, I guarantee you, if you were careful and you did not make any careless mistakes, would be x is equal to -5. That is a solution to this equation. And also x is equal to -1. These are solutions to the given equation, x squared plus 6x plus 5 is equal to 0. These are the only two solutions in the universe that will make a true statement for our given equation. Now let's take a look at a slight variation of this particular problem. All I've done here was rewrite the problem using some negatives here just to kind of give us a different aspect, a different problem, a different perspective. We have x squared minus 6x minus 5 in this case. So our values of a, b, and c might change slightly. A is the same. The coefficient of x squared is still 1. Since I changed that 6x to a -6x, I wanted to demonstrate how that negative impacts b. It becomes -6 is the value of b, and then -5 is the value of c. So now we'll work very carefully with these using the quadratic formula. We'll substitute those values into our formula. Remember that you are very careful because you end up with negatives and positives all over the place. And it's important for you to respect your signs because one careless error will give you an incorrect solution. Moving right along, we want to follow the order of operations. Make sure that we're careful. Notice this time what has happened underneath the radical sign. We end up with 36 plus 20. That 6 on the outside of the radical sign ended up being a +6 because you see how those two negatives impacted one another. And so now we end up with 6 plus or minus the square root of 56 all divided by 2. And note how